Students, I am going to discuss a problem of thin lenses. Problem is two thin convex lenses of focal length f1 f2 are separated by a horizontal distance d, where d is less than f1 and d also less than f2, and their centers are displaced by a vertical distance delta, as shown in the figure. Taking the origin of coordinates as the center of first lens, what would be the x and y coordinates of the focal points of the lens system for a parallel beam of ray coming from left of the lens? Okay, so here students, you have two lenses of focal length f1 and f2. They are separated by horizontal distance d and their center displaced by vertical distance delta. Okay, now we can take this parallel ray. This may be pass through the optical center of the first lens, so it will go undetected. Okay, now another ray that we can take the second ray from the optical center of the first, it will go undetected from the optical center, and but at this point it gets refracted this way, and the final focal point becomes F, and this coordinates is the y coordinates. Okay, and this is the x coordinates. If the distance is d, then x barabar d plus b. Okay, now this point, this is actually the focal point of the first lens. This distance is at 1. So this distance becomes f1 minus d, and the distance becomes this distance. Here this is this f1 minus x. Okay. Now for the second lens, at the distance, this becomes f1 minus d is the virtual object, and this becomes the final position of the image. So we can write 1 upon v minus 1 upon u is equal to 1 by f, or 1 upon b minus 1 upon f1 minus d. Here this is the distance f1 minus d, and this will be 1 upon f2, or 1 upon b is equal to 1 upon f2 plus 1 upon f1 minus d, or this will be f1 minus d plus f2 upon f2 f1 minus d, or this will give you v is equal to f2 f1 minus d upon f1 plus f2 minus d. Okay, so the x coordinate, this will be the d plus v. D is here and v is here, so x coordinate d plus v, this is equal to d plus v, is substituting this value f2 f1 minus d upon f1 plus f2 minus d. On simplifying, we get f1 f2 plus d f1 minus d upon f1 plus f2 minus d. Okay, now for the y coordinates, we have two similar triangles, one here and another one is here. So we can write this upon this distance is equal to this upon this distance. In similar triangle, we can write delta upon this, again this f1 minus d, and this is equal to y upon this distance, that is f1 minus x. Okay, so y is equal to delta times f1 minus x upon f1 minus d. Okay, now after substituting the value of x from this is the value of x, this is equal to, and simplifying, we will get delta f1 minus d upon f1 plus f2 minus d. Okay, thanks for watching the video.